Radio communications are performed constantly through a same space at the same time between different subjects without them disturbing each other. This is achieved by modulating carrier signals of different frequencies. These frequencies are internationally defined and are called channels. The rules for usage of each channel are also defined. So, for example, Channel 6 is reserved for ship-to-ship safety messages and communication with search and rescue and Coast Guard vessels and aircraft. Channel 24 is reserved for marine operator communications for the purpose of sending or receiving ship-to-shore phone calls. Radio signals on different channels travel simultaneously through the same space. The antenna captures all these signals simultaneously without any selection and sends them through the signal cable to the receiver. At the input part of the receiver, there are complex LC connections whose task is to pass only the desired channel and to dampen all others. Every LC junction has a resonant frequency. In the case of a serial LC connection, for an electrical signal whose frequency is equal to the resonance frequency, the inductive and capacitive resistance cancel each other out, and the serial LC connection does not resist the passage of such a signal. For all frequencies other than the resonant one, the serial LC connection provides electrical resistance, and such signals are attenuated. In the case of a parallel LC connection, for an electrical signal whose frequency is equal to the resonance frequency, the inductive and capacitive conductivity cancel each other out, and the parallel LC connection provides an infinitely large resistance to the passage of such a signal. The passage of such a signal whose frequency is equal to the resonant frequency is blocked. For all other frequencies different from the resonant one, the electrical resistance is not infinitely high and the signals of these frequencies pass through the parallel LC connection. By combined series parallel LC connections, better selectivity is achieved and only the signal on the channel used for communication is passed, and all other channels are attenuated. In order to change the desired channel and select a signal of another frequency, it is only necessary to change the resonant frequency to the desired value. This can be done by changing the capacity of the capacitor or the inductance of the coil. In maritime radio communication, the selected signal received from the antenna is an amplitude-modulated signal of very low power. In order to be able to process it further, it needs to be amplified using an amplifier. Since it is about relatively high frequencies of the signal being amplified, that amplifier is called a high-frequency amplifier. After the modulated signal is amplified in a high-frequency amplifier, it needs to be demodulated. The demodulation process is the separation of the modulating signal from the amplitude-modulated signal, the same signal that is obtained by using the microphone on the transmitter side, and with which signal we amplitude-modulated the carrier signal. After the demodulation process, on the receiver side, an electrical sound signal is obtained. This signal is amplified by means of a low-frequency amplifier. And the amplified signal is then fed to the loudspeaker, which, in contrast to the microphone, converts the electrical signal into sound.